right. Locking back in. Locking back in. We're being a little chaotic. Squirrely today. All right. Let's take a look at this bell work. These first ones are they're built a little strange. I promise it's for a reason. So we've got this 2 minus 3x, and we're going to go plus 5 plus x. What can I do to try and simplify this first one? Are these parentheses doing anything for us? Do I need to do any like distributing or anything like that? What's that one? Are those parentheses doing anything? Not really. What about these parentheses? Do I need to do any distributing or anything?
No.
Nah. I'm gonna get rid of them all. They're not doing anything. I don't have anything I need to distribute. I don't have anything that's being weird about it. So this is the exact same thing as if I had 2 minus 3x plus 5 plus x. It's the exact same thing. What can we do now? What can we do now? Combine some like terms. I've got two different sets of like terms here. I've got numbers. I've got 2 and I've got 5. And I've got my x's, my minus 3x and my plus x. So we've got our 2 plus 5. Well, 2 plus 5 is going to give us 7. And minus 3x plus x, thank you, it's going to give us a minus 2x. And we can write it like this, 7 minus 2x, or we could put minus 2x plus 7. Either way is fine. And that's it. Questions on that one? Look at the second one, very, very similar. But also a little bit different. So on the second one, we have 7 minus 3x minus 6 plus 4x. So what do we need to do there? Take off our parentheses. So these first ones, they're definitely not doing anything. Do I need to do anything over here before I can get rid of the parentheses? What? Distribute the minus sign. So the front, not the pen I went. There we go. The front set, I can just drop them. I don't need anything from that group. 7 minus 3x. But that minus sign, I need to subtract not just the 6. I also need to subtract that 4x. So we need to minus 6 and minus 4x. So we need to distribute the minus sign through. Now what do we do? What do we do next? What can I do here? Simplify this. That would be if I was just adding the two together. If I had this as a plus right here instead of a minus, absolutely. But we need to subtract them. Combine our like terms. I've got 7 minus 6. So that's going to give us a 1. and minus 3x minus 4x minus 7x. And that's our answer on that one. So combining like terms is going to be, something kind of important. We need to remember how to do that. Whether it's because it's 7:15 and our brains aren't booted up, because we're not actually looking and trying on these before I start talking, or whatever's going on, we need to make sure we know how to do that. That's like 4th grade. Bottom one is very much what we did yesterday. How can we simplify the square root of negative 12? So if I just give up and type it in the calculator, it's going to tell me domain error. Boo. Yesterday we did these a lot by dividing them up into pieces. What pieces should we break 12 up into? Or sorry, negative 12. So we usually break out that negative 1 by itself. And then what perfect square is a factor of 12? Because we are supposed to try them before I start talking. The point is for you to do them, not for me to do them. Let's to get your brains woken up in a math mode and review some stuff. Because some things might be really relevant for the stuff we're learning today. Sometimes it's, getting us ready for what we got to do. Oh my gosh. So we can split this up into negative 1 times 4 times 3. That still means negative 12. The reason we want to split the 12 up into 4 times 3 as opposed to something like 6 times 2 is because 4 is a perfect square. I want to always try and get a perfect square that will factor out of the number. Because I could rewrite this as our square root of negative 1 times our square root of 4 times our square root of 3. This guy is what we talked about yesterday. The square root of negative 1 is I. That is the imaginary piece. That's the thing that doesn't happen. It's the thing that's not real. It's made up to be able to finish a question. But it is a thing we have to know. Square root of 4. What's square root of 4? 2. And what's the square root of 3? Decimally and gross, and we don't know it. Ew. We're going to leave it like that. If it's decimally and gross, we're going to leave it in the radical. We just got to find the biggest perfect squares that can come out because we want this to be as small as possible. So we can write it as I times 2 square root of 3. Best grammar has us do it as 2I root 3. Either way's fine. It means 100% the exact same thing. It just feels weird for me to say I 2 root 3. It's like saying x4 instead of 4x. Just feels weird. Questions on this one? Or on any of these? Cool. Notes packet. Page 7. Shop. Same page we were on yesterday. Oh my goodness. We've got problems on the bottom of page 7 that look so much like those first two in the bell work. What? Shop. Relevance? What? Almost like they're there for a reason? Because these look 100% like bell work. Only thing different, aside from the numbers, is these guys used X's and these ones have I's in them. Doesn't change what we do. 100% the same thing. We're going to figure out how we can get rid of our parentheses. We're going to combine like terms. So for this first one here, we've got 4 plus 7i plus 2 minus 3i. I'm sorry, 2 plus 3. So those parentheses here, since everything's being added anyway, the parentheses aren't really doing anything. If I had a number in front of the parentheses that I would need to distribute through, that's when we would need to definitely do something there. If this was subtraction, we would need to distribute that over here. But I don't have anything happening in front of this parentheses, and this one's just a plus, so it doesn't really change anything. So this is 100% the exact same thing as if I wrote this as 4 plus 7i plus 2 plus 3i. 100% means the exact same thing. It's just been broken up into pieces. And then, just like in the bell work, we've got some like terms we can combine. I have some numbers. I've got a 4 and a 2. So 4 plus 2 is 6. We also have 7i plus 3i. What's 7i plus 3i? 10i. And just like the ones in the bell work, how we can't combine x and 2, like I can't put plus 3x plus 2 and have that be one thing, I can't add together 6 and 10i. They're separate pieces. They don't mean the same thing. So that's our answer. Very, very similar on the right one. There's just one extra step. Because instead of adding, we're going to subtract. So the important thing to know when we are subtracting these pieces that have imaginary chunks, I need to make sure that I am not just subtracting the 7, but I am also subtracting the minus 3i. So we need to distribute this minus sign through. This chunk, honestly, these parentheses don't have to be here. They're not critically important. There's not a number out in front that I would need to distribute. There's no powers on things. Nothing's going weird. So this is the exact same thing as if I had my 5 plus 6i, and then we distribute this minus sign through because I need to subtract the 7 and I need to subtract negative 3i. If we have a double negative like this, subtract negative 3i, what happens? It becomes a plus. Bless you. So if I have two negative signs, that turns into a plus. So it's really, really important that we distribute that minus sign through, but after that it is 100% the same thing, combining like terms. So when we combine like terms here, what are we going to get? Beautiful. Negative 2, that's coming from my 5 and my minus 7. 6i plus 3i gives us plus 9i. Beauteous. Questions on those two? We're going to practice this a couple more times. So let's look at 3 and 4, and then we might do 5. Well, we'll probably finish the page, so not super long. So we have another subtraction one here. Again, on this first term, I don't really have any need for these parentheses. They're not doing anything for us right now. So this is exactly the same as if I had my 3 minus 5i. But before I can drop these parentheses over here, I need to deal with this minus sign. we need to distribute this to both pieces. I need to make sure we're subtracting the 2 and we subtract that positive 7i. So we have to distribute that minus sign through. It makes a huge difference. We have to. And I strongly recommend writing it out because otherwise we lose track and we lose track of science. That is the number one issue that we get on these is we try and do too much in our heads. Write things down, please. So then let's combine our like terms here. What are we going to get?
Our paper says 3 plus 5i.
Oh, does it? Fun. Boop. 3 plus 5i. Yeah, if it does that, let me know. Okay, cool. There we go. 3 plus 5i. Anything else, Mencha? Mine has that too. Apparently I just typed it wrong. So what do we get when we combine things together? One and negative 2i. That's coming from my 5i minus 7i. Go ahead and try number 4. See what you can do. I could just hand this to somebody if you don't want to do that. Yeah, no, it's exactly right. What do we get? We finish this one. 8. Yeah, you're exactly right. Because I don't have to do anything with my parentheses. They can just drop. This is the same as 4 plus 9i plus 4 minus 9i. 100% the same thing. And when we combine things together, my 4 and my 4 makes an 8. We're good with that one. And then if I have 9i minus 9i, they cancel out. I have $9. I owe you $9. I now have nothing. You can put plus 0i if you would like to. If it helps you keep track that, yeah, we did that one. We just didn't stop in the middle. You're welcome to put it there. You don't need to, though. 8 is the exact same thing. So sometimes either our imaginary portion or our real portion will cancel out. These are pieces. These pieces that are in the parentheses here are called complex numbers. Not going to be a huge deal for us. It's one of those things that in pre-cal and beyond you will work with a bunch. So it's good for us to see them. But that's what these are. Okay. Questions on these ones? Okay. We have one more set of them. Let's do that. And then we'll look on the next page. So 5, again, is a subtraction one. So we're going to need to distribute our minus sign through. That's going to give us our 3 plus 6i minus 3. If we distribute the minus 3 to minus 3i, we actually end up with a plus 3i. We get another one of those double negative situations. So on this one, when we simplify it and get all the way down to an answer, what do we get? 9i. Because the 3 minus 3 cancels out. So again, if it helps you, you can put your 0 in there. You can put plus 0. But all we're left with is 6i plus 3i, so we get 9i. So when we're working with these parentheses things, these guys, these complex numbers, our answers could be imaginary numbers. They could be regular numbers, like our 8 on the last one. We could get like the 3 plus or 1 minus 2i, like we've got at number 3. Like totally fine. Sometimes the problem's going to be missing a chunk. So we've got 7i minus 4 minus 2i. That's okay. We don't treat it any different. Same deal. It's just already dropped the first set of parentheses. It's 0 plus 7i. So since we're subtracting again, I still need to distribute that minus sign through. Anytime we are subtracting, we need to distribute this minus sign through. It's super important. Because on this one, we're going to have our 7i minus 4 plus 2i. So we got to make sure that we cover those and deal with what they are. So when we combine these like terms together here, I don't have anything to combine with the negative 4. He's just going to chill. But we've got our 7i plus 2i. And that'll give us a 9i. And that's our answer on that one. Questions on our adding or subtracting with these things? Because we're not wanting to do it more with them. We'll get to multiplying them here in a minute. First, we're going to make something that feels like a very chaotic jump. But I promise it is relevant and tied to what we've been working with. At the top of page age, we randomly jump back into an equation. Yeah, feels real weird. And we're asked to solve this thing. Randomly out of nowhere. Really what it feels like. But, you know, textbooks make fun choices. Whenever we say solve, that means we're trying to get to an x equals. So every time it says solve, I want to try and get down to a solution. X equals. What could I do here to try and get my x by itself? Minus 36 on both sides. Absolutely valid. So let's take a look at what we get when we're done with that. We get 4x squared equals negative 36. Divide by 4, because I want to get my x by itself. So if I divide by 4 on both sides here, we get our x squared equals 36, negative 36 divided by 4 is negative 9. And if we're going to square root both sides, to get rid of that power on my x, I choose to do a square root on both sides. Whenever we are choosing to square root both sides, we need to remember to put a plus or minus. Because I don't know if this number, when it was squared, was a negative number that got squared, which is still positive, or a positive number that got squared, which will give us an answer. So we got to include a plus or minus anytime we choose to square root both sides. But then what is the square root of negative 9?
3. Negative 3.
3i. Remember, negative number inside the radical. That's my negative 1 times the square root of 9. So this is where those imaginary numbers came from. This is the point where mathematicians got so frustrated that they couldn't finish it and get to an x equals that they made up I. So remember, this is the same thing, our negative 1 times 9, so we could do our square root of negative 1 with our square root of 9, so that we could write this as our I times 3, or as plus or minus 3i. Again, I don't care if you put it as I3 or 3I. Both of them are correct. It just hurts my brain for me to write it as I3 as the final answer. If you put it as I times 3, it totally counts. It means the exact same thing. It just makes my eyeball twitch a little bit. So this is where those i's come from. Is when we have equations that we got negatives inside square roots and mathematicians got super frustrated that they couldn't finish solving it. So let's try the next one real quick. We've got 2 over here. We'll do 2. 3 is very similar to the first one, so we'll just do 2 so that we can look at the ones right below it. So the process on these kinds are very similar. So on the last one we did, our very first step was to start working on getting this thing isolated, get it by itself. So what should we do first? Minus 84. I want to get to an x equals, so I need to get my x by itself. That means I need to get my x squared by itself first here. So that gives us a 7x squared equals negative 84. And we can then divide both sides by 7. So we're going to have x squared equals, negative 84 divided by 7 is negative 12. And then we can square root both sides. And we're going to have that our x equals, whenever we do the square root of both sides, we've got to put a plus or minus, because I don't know if what had been squared was positive or what had been squared was negative. I don't have any way of knowing. So it could be either one. That's when we were going to have like 2 solutions. Oh, snap. And if we come in to try and simplify our square root of negative 12, how can we split that one up? What is a factor of 12 that is a perfect square? 4. And it would be 4 times 3 that makes my 12. So I want to find the largest factor of our number that is also a perfect square. 4 is the biggest one. So this guy turns into an I. This part turns into a 2. And that square root of 3, we don't know her. We only were like that. So again, I don't care if you write it as I2 square root of 3. Or if we put it as 2I square root of 3. I will write it like this because writing it like this makes my brain hurt. But it's not wrong. It's just one of those things that was drilled into me repeatedly. Okay. So that's where these I's are coming from. Is these kinds of questions that mathematicians got irked that they couldn't get all the way down to an x equals. We're going to go ahead and skip number 3. It's very much like number 1. It's a perfect square that we're going to know.
So we done it for today, right?
No, we got to look at the next row down. That's our last ones, is the products. This is our last stuff on this for today. Is to find the product. What does product mean? Multiply. So we need to multiply these 2 things together. How do we do that? Because if we had something that was like 3 times, I don't know, x plus 1, we know how to do that, right? We would distribute. Well, if I have more pieces, I just need to distribute them as well. So when we're multiplying these complex numbers is what they're called, the imaginary things. I need to take my first term times the first term. So we're going to have 2 times minus 1. That's going to give me a minus 2. I need to take my first term times the second term. So 2 times minus 4i. That's going to give us a minus 8i. Then I need to do the same things, but with my 7i. I'm going to go across the bottom on this one just so they don't overlap you too much. My 7i times minus 1 is going to give us a minus 7i. And then our 7i times minus 4i. Seven times our minus 4 gives us minus 28. And I times I gives us I squared. We need to simplify this as much as we can, including the I squared. Because we talked about this the other day. If we think about I squared, that's the same thing as our square root of negative 1 squared, which means that's the exact same thing as just negative 1, because the square root and the square cancel out. So I squared means negative 1. So this 28 times I squared is really minus 28 times negative 1. So it's just going to be a positive 28. This is going to end up being plus 28. At this point, all these other pieces are the same. I'm just going to copy them down so we're still looking at all the same pieces here. What else can I do to simplify this? Aside from dealing with the I squared. Yeah, now I've got a bunch of like terms. I have here a minus 8i and a minus 7i. It's going to give us a minus 15i. And we also have minus 2 and plus 28, which is going to give us a positive 26. So we're going to do our distribution. We're going to have to distribute both terms to the both terms. We're going to simplify, including the I squared, and we need to combine our like terms. Questions on this one? We're going to do at least one more. The third one will be decided on time. But that's all we got. So we're going to look at number 2. I want us to do number 3, but if we're too close on time, we'll go ahead and skip that one. So looking at number 2 here, this is 100% the same thing. We need to do our distribution, multiply all of the pieces times all the pieces in the other parentheses. So my minus 3 is going to need to multiply against my 2. It's going to give me a minus 6. And my minus 3 needs to multiply against my minus 6i. Negative 3 times negative 6 gives us a positive 18i. Just be really careful with your multiplication. The signs are honestly usually what gets us thrown off. So pay attention to the signs. A negative times a negative is positive. So then we have our minus 5i times 2. That's going to give us a minus 10i. And our last one here is a minus 5i times minus 6i. It's going to give us a positive 30i squared. So start by just doing our distribution. I highly recommend that you write every single one of them down and not try and do it in your head where we're combining things at the same time. That is where we run into mistakes. That's where we lose track of things. It's too many pieces to juggle. Write things down. What can we do next? What does I squared really mean? -1. So this is the same thing as if I had 30 times -1. So we can simplify this in any order that we want. I could combine my like terms together right here. Totally valid. I could take this through and combine together my 18i minus 10i. It's going to give me an 8i. So now I have -6 plus 8i plus 30 times -1. What is this going to simplify down to be? We have our -6 plus 8i minus 30 once we do that multiplication. So finish combining our like terms. -36 plus 8i. Okay. Questions on this one? So we've done these kind of multiplying things before. The weirdest part on this is that I squared turns into -1, so we have extra things to combine together. So there is absolutely nothing wrong with problem number 3. It's a great one to do. We're just 2 minutes till the announcement reminder, and I want to make sure you guys have a little bit of time because I know we don't get very much of it. There we go. I've got homework 3.3 due tomorrow because that has our complex number stuff on it. If we need an extra day on it because there's a lot of things on there, I totally get it. So if you need to give it to me Monday, that's fine. It's just technically going to be So work on trying to get stuff completed and turned in. Our chapter test is on the 24th. So it's not until after fall break. Huh? What's that? Okay. I was like, I genuinely didn't know what you said. It was not judgment, it was confusion.